Hello and very warm welcome to the channel. This channel is all about AI and data driven applications. This is what I'm going to record videos on. This is what I'm going to post in this channel. Now, this particular series is all about practical generative AI for beginners. So now we know that AI, specifically when you refer to AI, we are talking mostly about generative AI nowadays. And everyone, even the common man on the street, is aware of what ChatGPT is. So this series is particularly focused on that. So what this series is all about? Now, first of all, this is targeted towards newbies and anybody who's curious about knowing how AI works and what it can do. Then this series will particularly talk about the practical, real world, useful generative AI application. That means the applications that we are going to build, they are not going to be just a toy application. These will be initially will be simple application, but is still useful, as you will see. You can use it in day-to-day life. So they won't be throwaway applications. So effort will not be wasted. Secondly, obviously this is a hands-on series. So we'll be getting our hands dirty and we'll be doing a lot of coding and a lot of setups, deployment, etc. So this is hands-on tutorial or series for agentic generative AI applications. So now any modern application that you will see nowadays or in few years time, this will be going even further. They are all agentic application. That means there's a lot of things is done by application themselves. They make decisions, and that's where the power of generative AI comes in, as you will see that how it works, and it just mind blowing what these application can do. Secondly, we are going to build everything from scratch. As I said, this series is all about generative AI application for beginners. So no prior knowledge of AI or generative AI is assumed, and we'll be starting from very, very basic. So we'll be learning about theory. We'll be learning about tools and how to set them up, what tools are required, important techniques, and complete code. So we'll be coding it from ground up. And then not only will be building this application, we'll be deploying these application in cloud, like any production application is nowadays deployed. And then we'll also look at how to monitor these applications if they are running in production. Now, this is the list of topics, and it is a tentative list right now. It will grow and evolve as we go, but this is what I have in mind and I'm going to cover. The first, I'm going to talk about the prerequisite of this series and generative AI introduction and the history. So these two topics will be covered in this video, and the rest will be covered in following videos. The third one is the LLM introduction, and this is by far, I think this is the most important video that I'm going to record. And in this video, we are going to talk about the crux or the heart of any generative AI application, which is large language models. As you must have heard about ChatGPT, if you use Anthropic or Gemini or any other chat applications, right? So on the back of these applications, there is always a large language model. So we are going to learn about everything about large language models, what they are, briefly how they work, what they can be used for, what they are good at, what they are good, what they are not good at, everything. Then next video, we are going to start setting up the stage for application building. So we are going to learn how to set up the required tools, basic tools, which definitely we need, and we'll be setting up more of these tools in future video. But in this video, which I'm going to record in future, obviously, we are going to set up all the basic tools that we need to start building it. Then we are going to learn very important frameworks that we are going to use in this series, LangChain and Gradio. Using these tools, the application development of generative AI based solutions become very easy. And after we are done with these basic steps, then we will straight away jump on building some exciting projects. The first project we are going to tackle is a stock analyst. You will see that the building this project will not be very difficult. in terms of coding and setting up everything, but the things that the application is going to perform and the analysis that is going to perform is not trivial. But thanks to large language models and their capabilities, it makes our life very easy. So this is going to be the first very exciting application. Then second application, we are going to take our knowledge a notch above, and it will be a bit more complex than a stock analyst. The application will be a brochure generator. So given a company's website, the application is going to pull all the relevant information. It's going to generate a very good brochure for its customer, for its suppliers, prospective employees, right? And this is going to be fun. And then obviously no generative AI application series is complete without talking about the chat application, because nowadays when we talk about artificial intelligence, then we first thing that comes to mind, at least in general public mindset, is the chat application. So you log into, let's say, chat GPT, and you fire away your question. So we are going to build our own chat application from ground up, so you'll know that what goes behind building these chat applications. And after that, we are going to explore open source models. So now till here we are mostly till chat application will be focusing on frontier models, which are the models developed by large companies like OpenAI, Microsoft, Google, Anthropic, and these guys. And these are paid models, but they are very, very capable models, right? But downside of these models are that we as a data scientist or LLM engineers or developers, we cannot make changes. At least we can train them. There are facility provided by these models to add your own data and train them, but it's pretty hard. You don't have full control on them. So that's where the open source model will come into the picture. These are the models which are open sourced, available to publics. So we'll be start looking at these open source models and fine tuning them to our needs, to our own data, and you will see that how powerful this technique is. And best part, these are free, so you don't have to pay anything for them. Okay. And then we'll jump onto something which is essential for building applications. Practical and complex application is RAG and agentic application. RAG is a technique by which you provide a superpower to your generative AI application. You give them access to external world and the environment. For example, you give them access to external database. You give them access to your private data set, private documents, internet, and then it becomes a totally different ball game what you can build with them. And it goes hand in hand with agentic application. As I mentioned earlier, these are the state of the art applications are nowadays are agentic application, and much more. That means this list obviously is not complete. This is what I have in mind right now, and this is going to evolve over time, what we are going to learn. Now, the first thing, as I said, prerequisite. There are some prerequisite for this series. Obviously, the everything will be coded in Python. Python is the de facto language for all AI development right now. And there are other languages like JavaScript, and even in Java and Go. There are libraries available in Julia and other languages. That's possible, but Python is by far is the de facto standard, and there's a lot of libraries available. So that's what we are going to use. So if you know Python programming, then you're all set to proceed. And you need not be an expert in Python. Just the basic Python construct, looping, object-oriented fundamentals. If you know that, then you're all set. No problem at all. Now, if you don't know Python, but you have some programming experience, that means you have programmed in other languages, like let's say any language, C, C++, JavaScript, whatever, doesn't matter, but you have some programming fundamentals with you, then you just need to pick up Python syntax and basics fundamentals, and then you should be good to go. Python is not very hard language to learn. It is very easy, very intuitive, and for the beginners, probably this should be the first language that you should be picking up. So I'll be showing you a few resources that I'll be leaving in the description as well. If you have some programming experience, this is the video that you can start with. There are many of them, but I like this. This is a channel by a gentleman called Mosh Hamadani, and he's a very good instructor. And in fact, I have a soft corner for his content, because when I started doing my masters in data science, then I was mostly a C programmer then, so I wanted to learn Python, and his channel was the channel which I went and learned from him. So this his very good instruction is an excellent resource for learning Python. You must check this out. I'll just in a bit I'll show you how it looks. Then if you have no programming experience at all, then still it's not a problem, because Python, again I said, Python is a very easy language to learn, and this is the resource I recommend, and it is excellent resource for learning anything about Python. So even though you have progressed a lot in your career as a Python programmer, this is the resource. If I have to, I'll come again and again to check, because there is enormous content on Python, and they keep updating this. And if you're starting it, they have a learning path called beginners basics, and this will help you a lot. So let me just go and just show you like what do I mean by that. Okay. All right, so this is the channel I was mentioning about, the Mosh Hamadani, and this is the video link which I'll leave in the description. So this is 2 hours video. It's not very long, and he has another old videos. They are 6 hours long, 1 hour long. So what I recommend, if you know some programming construct and you have some experience, then 2 hours course in Python is more than enough what you need to start with. Now, for the beginners, if you are just starting to program and you have never programmed before, then probably you should start with here. That's my recommendation. Obviously, these are not the only tools available on the internet, and you have a lot of beginners book, but this is what I recommend if you want to check them out. So the first is the absolute basics, and this is where they start from scratch, like what is a variable, defining a variable, loops, everything from the very beginning. And it will help you a lot if you are planning to start your career as a Python developer or a data scientist. If you're like me, when I started, I didn't have Python background, so I went to Moss Amadani videos and I learned from there. But I had programming experience, a lot of programming experience, so that was easier for me to pick up. But if you're starting, this is where you start. So in this, if you go in this, I recommend you finish this till 11. So they have various sections in this, and till 11, where they teach about object-oriented programming. There are more sections here, and you're more than welcome to go and check. But this is not essential. You can learn later on as well. But till 11 is the very core basics that you must know to proceed with the series. Then if you already know and you want to learn more about Python, then probably you can start from here, which is learning path is revisit Python fundamentals. So they will breeze through the Python basics, and they add few more advanced topics, and you can go even further. There is, as I said, there are a lot of resources in here, but for beginners, definitely you must complete this basic part. So this is what I wanted to tell and put it very clearly, that these are the prerequisite, and it's not very hard. Python can be picked up. It's a fun language to learn. So I'm sure that you will start and you will learn. So let's move on and continue. Let's quickly look at the genesis and the history of generative AI, which I personally find it very intriguing. So the way I look at the current state of things is in 2 parts. So the first one is the traditional AI, which is, we can say, machine learning. It's not the exact lingo, because generative AI is also kind of subset of machine learning. But for understanding, I say machine learning, where we are more concerned with applications where we need to draw insights from the data, like analytics. So for example, let's say there is a bank and it has a big customer base, and it wants to find out that which are the customers they'll be interested in more premium product which they are coming up with, right? So for that, the input they have is a data, transactional data of the customer, plus the personal information of the customer, right? And based on this, they also have what they have been doing in past, and based on this input, probably they can draw insight in finding like what type of customers would be interested in our premium product, so that we can basically target these customers specifically, right? That will be more optimal for their business. So this is kind of analytics or insight based application or solutions that machine learning enables us. Another is very famous is the prediction, right? So let's say given a lot of weather condition, a lot of weather parameters, can we predict that there'll be rain, or there'll be some kind of tornado coming in, blizzard or something like that. So based on a lot of environmental condition, can we predict that? Based on what in past we have seen, the model will learn, and in future, if the same or similar conditions occur, then model will be able to predict upfront. For example, jungle fire, right? In forest, recently there was a big issue in California where fire was spreading like anything. So is it possible to predict upfront these events based on the past data we have? And this is where the machine learning is very good at. Last one is a classification task. And for example, let's say given the diagnosis data of a bunch of patient, let's say blood sugar, weight, age, these things, can we predict, or can we classify this patient into chances of they are getting diabetes or not getting diabetes, right? So this is a binary two class classification. It can be n class classification as well, right? So for example, telecom company can classify their customer in three categories. One is what are the chances that customer will leave, definitely leave the subscription service or their platform. Then customer who are loyal, they'll be stay, and the customer who are kind of in between, they are not able to make up their mind, and this is where they want to target these customers so that they can turn it and make them stay with the platform, right? So this is where the traditional machine learning comes in, which predicts information based on the past data, right? In the known domain itself. Now generative AI is a bit different. As the name suggests, generative means it generates original and new content, which has novel content which has never been seen before. And we do this nowadays on our mobile devices. We do every day. I mean, people give description and generate a lot of images which has never been seen before, right? So new image creation, new article which was never written in past, you can create, right? You write your emails using generative AI chat applications, and this email was never created in past, right? So these are authentic, real, original content, and that's where these two streams, even though there is in terms of their actual mechanics and how they learn and do things, so there is overlap, but in terms of output, they are very different. And second one is obviously the subject of this series. Now, in terms of history, obviously there is no clear cut. There's a lot of debate, like where it started. Some people say it started in somewhere in 1700. Some mathematician already thought that using math, it's possible to generate artificial or kind of machine learn or do things, right? I'm not too sure about that, but definitely one thing is in written literature and what I know and through on internet, one thing is kind of accepted norm, accepted Time is that in 1950s, probably this serious thought about artificial intelligence started, and one credit goes to British scientist Alan Turing. So anybody who is from a computer science background, he will know who Alan Turing is. They had to learn something called Turing machines. So you definitely will be familiar from if you are from computer science background. If not, he was a British brilliant scientist, and he first time uh, came up with the idea. Two words he put together. He said, "Can machine think?" So machine and think. So this was the kind of turning point. Like machine, like humans, can it think? And he came up. He published a paper in 1950 called "Imitation Game," where he described like what he's thinking. In internet is freely available. If you just search "imitation game Turing paper," then you'll find it. And there is a famous movie on this as well, very interesting one if you want to watch it. So possibly this is where the thought process started of machine and thinking. And then in 1980s, the 90s, there was something called neural network that came along. The experiments were conducted long back, but actually the real application and the output that came somewhere in this period. So neural networks are something they're designing a computer system which kind of not mimic, but is kind of inspired by human brain. So neural comes from our neuron cells in our brain, and the whole concept is based on that. So can machine think, and can we design similar to how our brains is wired and designed? And famous architecture based neural network based are CNN and RNN. CNN is a convolutional neural network, and till very recently this was the state of art architecture to be used for any image recognition. For example, a lot of self-driving cars and which were still being built. So vision based application, they still use CNN as their architecture. Another one is RNN that came, and that stands for recurrent neural network, and these were specifically designed for working with natural language. And the word recurrent comes from the nature of natural language, because natural language, the way we speak, it's by nature it's ambiguous, and unless you give a context to someone, right, he will not be able to understand one sentence in isolation, and he might misinterpret it. So you have to give the full context. That means in order to understand a natural language, few lines or paragraph, you have to provide the full context. So this whole thing has model, or the machine or the system needs to have knowledge of what has happened in past. So that has to be fed to this again and again and again. That's why the name is the recurrent comes. And this was one of the problem why the natural language processing lagged in terms of adaptation in artificial intelligence. And this whole thing, and because just quickly, and the problem was the recurrent neural network based architecture was because everything has to be fed again and again, everything has to be done in sequence. So no matter how powerful your computer is, the paragraph or the sentence has to be processed word by word, one after the other, and this requires a lot of compute power, and it will slow things up. Okay, and as your sentences become longer and longer, it was impossible for a model to remember everything. Nowadays, pretty common for us to take a 200 line of big paragraph and just put it in chat GPT and ask questions, right? It was not possible when new RNN based architecture were used for processing natural languages because of their sequential processing. And then in 2017 something changed completely. There was a paper published by scientist from Google called Transformer, Attention is All You Need, right? And this is probably the most important and the trigger for all the development and all the advancement that you see in nowadays we are aware of, we use it every day in AI field, called transformers. And based on this, in 2018, OpenAI, so everybody knows who OpenAI is, they created a model called GPT-1. So GPT stands for generative, pre-trained, and T stands for transformer, this transformer. So based on this paper, they first created the very first uh, large language model called GPT-1. And then 2022, I think in October, everything changed when OpenAI released their chat GPT. So till 2018, everything was happening behind the scene. People in the field or in academia, they were aware, they're experimenting with. But in terms of general public, they were not aware like what's happening and how to use it. But in 2022, OpenAI released ChatGPT, which was based on GPT 3.5, much later version of GPT-1. And this is where, as we know, where we are. So ChatGPT changed the whole scenario of artificial intelligence, and these were can be attributed to this seminal paper that was created by Google scientist. uh, so let me just quickly, I just want to show it. So this is the famous paper. It's I think 15 pages long. uh, this is where all it started. So one key phrase in abstract which I see is this is what I was mentioning, right? So they develop a architecture they called a transformer, and they are saying dispensing the recurrence and convolutions entirely. So this is where they made it possible to process enormous amount of text to corpus parallelly, and this changed everything. And this is the crux of where we are going. There's no stopping because large amount of text can be processed very fast. So obviously, if you want, you can go through, but I must tell you, this is not an easy paper to read if you're not mathematically inclined and if you're not studied machine learning in detail. So definitely, it's not required for learning how to develop Gen AI application. Is definitely not a prerequisite for the series, but it is just for info that this is the origin, the genesis, and this is the very famous transformers architecture. Obviously, we do not need to understand it. What is that? It's a pretty complicated architecture, and unless you deep dive into maths, it's hardly you will get it what's going on. But definitely, just keep in mind. I just wanted to show, but this is definitely we do not need to understand in detail. But you will see this picture again and again in a lot of papers. Everything is based out of this. But if you are interested in learning more, then I can provide some resources. I'll leave the descriptions of all these, link of all this in the description. So obviously this is the paper. Then when I was trying to dig deep, when I was trying to learn, I found this video, right? Without going in too much math, this gentleman called MetaLlama, I think he works for a AI company called Cohere, and they also have a very powerful LLM. And he, in this video, he tries to explain it intuitively, like what exactly in this architecture, right? Layer by layer. So these are called layers. What's happening without going too much in maths. And so using diagrams and animation, he would try to explain. So it would start making sense. Like, okay, fine. Oh, aha, kind of aha moment. Yeah. Oh, all right. So this is how it works, right? So obviously this is a very brief half an hour video. Everything cannot be understood and explained. So recently he has published a book as well, and it's by MetaLlama, as you can see, and this is more detailed. So in this case, he breaks down every piece of transformer architecture and explains like how LLM works. Even the math is also explained. Then there's another resource I find very useful and very pleasing is from I don't know, it's a group of people probably. It's a YouTube channel called 3 Blue 1 Brown, and this channel is dedicated on maths mostly, but they also have videos like this video is on large language model explain, and they explain with lot of graphics and animation. So it's easy to comprehend, to be honest, and I have watched them again and again. It's just check them out, it's very good. So here is another one where they explain how transformer works, and there are a few more videos. So I'm going to leave the link in the description, and here are all the videos which I just showed. So I'll leave the links in the description, so probably you can check them out. All right, so I think this is what I wanted to cover in this first intro video. So I think this should have given you enough information, like what this series is all about and what you need to know, and a bit of history as well. So from next video onwards, we'll be jumping deeper. In the immediate next video, I'm going to go through what large language models are and what they do, and what we need to know about them in order to proceed further for developing application. So till then, see you, and bye for now.